Okay, welcome to the second video of a three-part series where we're looking at this handout that describes the formation of molecular compounds, synthesis of molecular compounds, where two nonmetals, or at least two atoms of two nonmetals, are joining together. So we're going to look at this one here where hydrogen and chlorine join together. Again, hydrogen is a nonmetal, even though it's on the left-hand side of the periodic table, over here. And chlorine is a nonmetal over here on the right side of the periodic table. So let's just get into it. So we see here for hydrogen has one valence electron and a core charge of +1. Where are we getting that information? Well, again, hydrogen is in group 1A. So the group number is going to tell us those two pieces of information. The fact that hydrogen is in group 1 tells us that it has one valence electron and a core charge of +1. You'll notice in the diagram here as well that hydrogen is drawn smaller than chlorine. Well, why is that? Well, first of all, hydrogen is over here on the left-hand side in the first period, whereas chlorine is over here on the right-hand side in the third period. And remember, as you move down the group, or as you move downwards in the periodic table, you're adding more and more shells to the atoms. So chlorine is going to end up being a larger atom. Okay, chlorine, it says right here, has 7 strongly held valence electrons and a core charge of +7. It has room for 1 electron. Okay, so chlorine is in group 7A. So that's where we get the idea that it has a core charge of 7 and has 7 valence electrons. But it also says that they're strongly held. Well, where are we getting that particular idea? Well, it's the fact that chlorine is in group 7 and has a +7 core charge means it's strongly electronegative. So it's really good at holding its electrons, but also trying to steal other ones. Okay, and you can see that right here in the diagram that there's an arrow going from hydrogen's electron to that empty spot on chlorine. So chlorine is attracting its own electrons, but also the electrons of hydrogen. And it has room for 1 more because, again, that in that valence shell of chlorine, we can get a maximum of 8 electrons. And chlorine has 7, so it has room for 1 more. So it's going to try and fill that valence shell by stealing from hydrogen. Again, hydrogen is smaller because it's further up on the periodic table. So hydrogen's electrons, if you look at the second column, hydrogen's electron is strongly attracted to chlorine's core. Again, chlorine is more electronegative, mostly because of its larger +7 core charge. And again, that arrow is showing that pull of the electron from the hydrogen to the chlorine. Over here in the third column, it says hydrogen fights back. Well, why does hydrogen fight back? It doesn't want to lose its electron. Nonmetals tend to be stealers of electrons. Metals tend to lose their electrons, so hydrogen, being a nonmetal, is going to fight back. But, I mean, hydrogen's core charge is +1. Chlorine's is +7. You would think that hydrogen would be pretty weak and wouldn't be able to hold on to its electron. Well, the fact is hydrogen is also a smaller atom, and so that kind of compensates a little bit for the smaller core charge of +1. So hydrogen will fight back because of its smaller size. And you can see right here, instead of the electron being completely stolen, hydrogen's valence shell is being stretched out. Chlorine is pulling on that electron and hydrogen is fighting back, and so hydrogen's valence shell is being stretched instead until there's a resolution to that tug of war. When we look at the last column, you can see now that tug of war has been resolved. You can see here that hydrogen's valence shell is overlapping chlorine's valence shell, and that's where that covalent bond is going to happen. So both atoms end up sharing the valence electrons in a covalent bond. And you can see here where the hydrogen's valence shell crosses chlorine's, here and here, we have a pair of electrons. So a covalent bond really is a sharing of a pair of electrons. And so this tug of war that was happening over here in the other diagrams has now been resolved, and both atoms are happy. Hydrogen only has 1 shell. It has a maximum of 2 electrons. So you can see here there are 2 electrons that are being shared, so that makes hydrogen happy. Chlorine had, originally had 7 electrons. It needed 1 more, and it got that from hydrogen. So chlorine is actually, if you look around it, well, it has 8 electrons. But again, that's only accomplished by that sharing of electrons. So both hydrogen and chlorine are happy. Okay? We'll see you in the third video.